Europa is usually sold as one of the most exciting places in the solar system. A frozen moon, a global ocean, maybe the best nearby place to look for life. All of that is true, and it still misses the real story. Because Europa is not just an ocean world. It is a pressure trap, a place where every layer you move through makes the environment less forgiving, less accessible, and more hostile to machines than the dream version suggests. From a distance, Europa looks simple. Bright ice, dark cracks, a clean white moon orbiting Jupiter. Up close, it becomes a stacked problem. And that stacked quality is the first thing most casual coverage gets wrong. People tend to imagine Europa as a single discovery waiting to happen. Build a lander, drill through the ice, find the water, look for chemistry that might point to life. But Europa does not offer one problem. It offers several problems sitting on top of each other, each one capable of degrading the one below it. That is why the right mental image is not treasure under ice. It is a high-value target protected by layers of punishment. Start with radiation. This is the part that changes the mood of the entire mission before anything ever touches the surface. Europa lives deep inside Jupiter's radiation environment. That means electronics age faster. Exposed systems take a harsher beating. Surface operations become time-constrained. Communication windows, shielding trade-offs, instrument survivability, and mission sequencing all change before the science even begins. In other words, Europa does not begin as an ocean mission. It begins as a survival against Jupiter mission. That distinction matters because it changes how you think about success. A normal exploration fantasy says the mission begins when you arrive. A Europa mission begins well before arrival, because arrival itself only matters if the spacecraft is still healthy enough to use the time it has left. This is one reason Europa Clipper is so strategically important. It is not landing. It is orbiting Jupiter and repeatedly flying past Europa instead of sitting on the surface and soaking in the radiation non-stop. That mission design is not a compromise born from lack of ambition. It is a response to environment. Europa is teaching us that access to an interesting world is controlled by the larger system around that world. And Jupiter is not scenery in this story. Jupiter is the first gatekeeper. Then comes the second layer, the surface. People hear ice and instinctively picture something uniform. A crust, a shell, a barrier with thickness, yes, but with basic geometric simplicity. Europa is much messier than that. Its surface carries fractures, ridges, disrupted terrains, chemical alteration, and regions whose history is still debated. Even from orbit, the moon looks like a place that has been pulled, cracked, shifted, and rewritten many times. That makes it visually beautiful. It also makes it operationally ugly. Because a surface that looks scientifically rich can be mechanically hostile. A place that seems promising in an image may be terrible for landing. A place that seems flat enough for contact may say almost nothing about what lies underneath. And a place that seems likely to expose useful chemistry may be the exact place where radiation has most aggressively reworked the upper material. That is one of Europa's recurring tricks. The scientifically tempting site and the operationally safe site are not guaranteed to be the same site. So even a lander is not just a lander. It is a negotiation between radiation, terrain, instrument priorities, communication constraints, and the simple fact that a heavy machine has to survive touchdown on a world that does not care whether our favorite hypothesis gets a clean test. Now assume you solve that. Assume you survive Jupiter's radiation long enough to reach Europa. Assume you land safely. Assume your systems are still healthy. You still have not reached the real barrier. The ocean is below all of it. And between your spacecraft and that ocean is uncertainty. uncertainty about ice thickness, uncertainty about structural variation, uncertainty about how local conditions differ from global assumptions, uncertainty about what kind of descent method even makes sense once you stop talking about neat diagrams and start talking about actual alien ice. This is where Europa stops being a romance and becomes an engineering discipline test. On Earth, we know how to drill through ice. Poorly, slowly, expensively, but we know how. And when Earth crews drill through ice, they do it with support. People nearby, repair chains, resupply, open air above them, specialists within reach. Europa gives you none of that. Any descent system has to carry its own survival logic with it. Power, heat, sterility, navigation, communication strategy, fault tolerance. And one of the cruelest parts of the Europa problem is that the machine gets more vulnerable exactly when the mission becomes most valuable. At the surface, you can still say you made it. As you descend, the path gets darker, stranger, and more expensive. Every additional meter of penetration makes retreat harder, and the science potentially richer. That is the structure of a trap. The reward is real. So is the commitment cost. And then there is pressure itself. Not only the intuitive pressure of an ocean under a thick shell, but the broader idea of environmental compression. Thermal gradients, mechanical load, chemistry that does not behave like a clean laboratory system. Europa is attractive because liquid water may exist below the shell. But liquid water in a planetary environment is not automatically friendly to instruments. Everything you send down there has to endure the transition between frozen surface logic and subsurface ocean logic. That means seals matter, materials matter, sampling chains matter, and contamination control matters almost more than people realize. This is one of the reasons Europa is such a brutally honest science target. If life is part of the appeal, then contamination is part of the fear. The mission is not only about reaching the ocean. It is about reaching it without ruining the meaning of what you find. That is harder than most popular coverage admits. Because contamination is not just a biological concern. It is an interpretive concern. A compromised sample chain can produce a result that is not simply wrong. It can produce a result that looks meaningful and wastes years of scientific confidence. Imagine the first strong biosignature claim from Europa arriving through a dirty or ambiguous pathway. The world would react instantly. The scientific damage would last much longer. Europa punishes shortcuts because shortcuts do not merely reduce elegance. They reduce truth. There is also a deeper systems issue here. Power. Any Europa mission serious enough to move beyond surface contact has to confront one brutally boring fact. Interesting science in hostile environments is often an energy problem. Heat for melting or drilling, energy for computation, energy for transmission, energy for survival during long operations. And on Europa, energy is not just a line item, it is a governing equation. The farther you push into the mission, the more every watt has a job to do. This is where many science fiction versions of the story quietly cheat. They assume the machine's job is exploration. On Europa, the machine's job is first to stay alive long enough to explore. That makes Europa one of the best examples in the solar system of the difference between interest and access. A world can be enormously interesting and still punish access so severely that every layer of exploration has to be rethought. That is exactly what gives Europa its power as a channel topic. It is not just mysterious, it is structured mystery. A world where each answer is physically protected by the environment around it. Even communication becomes part of the trap. A surface lander is one problem. A descent system moving through the ice is another. How do you maintain link quality? How much autonomy do you trust on board? How much can the system decide for itself if signal quality falls apart? How much data do you preserve versus transmit in real time? These are not cosmetic decisions. They shape whether Europa science is episodic or continuous, robust or fragile, interpretable or compromised. That is why Europa is such a useful contrast to other famous exploration targets. Mars looks difficult because it is vast, dusty, and operationally expensive. Europa looks deceptively clean, and that visual cleanliness can fool viewers into thinking the mission logic is simpler than it is. It is not. Europa is not clean. It is layered. And layered environments are some of the hardest environments we ever try to study. Because mistakes compound. You can solve the transit problem and still lose to radiation. Solve the radiation problem and still lose to landing. Solve the landing problem and still lose to ice uncertainty. Solve the ice problem and still lose to contamination. Solve the contamination problem and still lose to power or communications. That is why Europa deserves the framing of a pressure trap. Not because it is hopeless, because it is disciplined. It forces discipline out of every mission that wants to matter there. And that is exactly why Europa remains one of the best places to look for life. The difficulty is part of the scientific value. If we can investigate Europa properly, we prove something bigger than whether one moon has interesting chemistry. We prove that humanity can do layered science in a place where the environment actively resists shallow interpretation. We prove that our exploration systems can stay clean under pressure. We prove that our engineering can survive not just one hazard, but a chain of linked hazards. And if we fail, that lesson matters too. Because Europa would be telling us something honest. Not every interesting world is reachable by charm, hype, or ambition alone. Some worlds demand technical maturity before they release their meaning. Europa is one of them. There is another reason Europa is such a hard world to explore honestly. It punishes imagination that runs ahead of systems thinking. Ask almost anyone what the ideal Europa mission looks like, and they will give you some version of the same answer. Land, melt, reach the ocean, release something that can swim, find life. That sequence is emotionally satisfying because it feels direct. But direct is not the same thing as realistic. Every part of that fantasy hides a stack of operational questions. How does the system maintain orientation during descent? How much path awareness does it need? What happens if the melt channel begins closing behind it? How much material gets transported downward and threatens sample integrity? How do you prevent the mission from becoming a heat experiment with a science payload attached, instead of a science mission with a survivable descent method? These are not side questions. These are the mission. And this is one of Europa's biggest strengths as a media topic. It forces viewers to confront what exploration really is. Not a single machine doing one dramatic thing. A chain of dependencies that must stay coherent under stress. That same logic applies to planetary protection. People often hear that term and translate it into a simple moral rule. Do not contaminate the interesting world. That is true, but it is still too shallow. At Europa, planetary protection is not just about ethics. It is about preserving the meaning of first contact, the first convincing chemical hint, the first sample from below the surface, the first sign that something there behaves like biology instead of geology. If those moments are ambiguous because the chain of custody is weak, then the mission may still produce headlines, but it will not produce confidence. And confidence is everything in a discovery this big. That is why cleanliness at Europa is not a nice-to-have layer added after the bold engineering. It is one of the central engineering constraints from the beginning. If your descent system sheds contaminants, your best data can become suspect. If radiation has altered the chemistry you are sampling, the interpretation gets harder. If the melt path, instruments, or storage chain compromise the signal, the whole discovery logic gets weaker. Europa is a place where bad process can imitate bad luck. That makes disciplined design essential. The same thing is true of autonomy. A Europa mission attractive enough to matter will almost certainly have to make more decisions for itself than most people imagine. Autonomy is a fashionable word in exploration, but on Europa, it is closer to a survival requirement. The machine may need to manage power states, thermal states, sampling decisions, fault responses, and communication priorities with limited outside intervention. And that changes the burden of software. Software is no longer merely a convenience layer on top of hardware. It becomes part of the mission's scientific credibility. If the system makes a poor onboard decision, you might not simply lose time. You might lose the only clean attempt at a measurement. That is another reason Europa is so unforgiving. It is not just physically harsh, it is decision harsh. And those decision pressures continue even if you imagine more modest mission goals. Suppose the mission never reaches the ocean. Suppose all you do is characterize the surface and near subsurface better than ever before. Even that more conservative mission still depends on radiation-tolerant design, landing logic, smart instrument prioritization, contamination awareness, and the discipline to avoid overclaiming what a partial result means. Europa is difficult at every ambition level. That is why it remains so compelling. A world like this turns humility into a mission requirement. You cannot bully Europa into being easy. You can only build systems honest enough to survive it. And there is one last strategic reason the world matters. Europa sits inside a broader argument about the future of exploration. Are the best targets the ones that are easiest to reach, or are the best targets the ones that are hardest to study, but most likely to change our understanding if we do study them well? Europa belongs decisively to the second category. It is expensive in every sense. Expensive in propulsion logic, expensive in shielding, expensive in landing design, expensive in contamination control, expensive in patience. But that expense is what gives the target its meaning. If we can build missions good enough for Europa, we are building more than one moon program. We are building the methods for investigating layered hostile worlds throughout the outer solar system. That is why Europa is not just an astrobiology story. It is a maturity story, a test of whether our curiosity is finally disciplined enough to meet an environment that offers extraordinary payoff only to extraordinary preparation. That is why the old label, Ocean World, is technically correct and strategically incomplete. Yes, there may be a global ocean under the ice. Yes, that makes Europa one of the most compelling astrobiology targets near Earth. But the ocean is not the story by itself. The story is the barrier system above it. Radiation punishes the approach. Terrain punishes the landing. Ice punishes the descent. Contamination punishes sloppy science. And the mission architecture punishes any false assumption about how easy it will be to turn curiosity into knowledge. That is why Europa matters so much. Not because it is simply beautiful or mysterious, because it is one of the clearest tests of whether we can do serious exploration in a place that is both fascinating and hostile at the same time. If you want space explained by consequence, subscribe. The next briefing is about the Webb measurement that still refuses to fit our best model of the universe.